Welcome back to Learn with Knowledge X. Today, we're diving into the fascinating science behind everyday phenomena. Have you ever wondered why the sky is blue, how soap cleans, or what makes ice cream so delicious? Stick around to find out. First up, why is the sky blue? The answer lies in a process called Rayleigh scattering. When sunlight enters our atmosphere, it collides with molecules and tiny particles. These collisions scatter the light in all directions. But here's the catch. Blue light waves are shorter and scatter more than other colors. This scattered blue light is what we see when we look up during the day. As the sun sets, the light has to pass through more atmosphere, scattering the shorter blue and green wavelengths out of our line of sight and leaving behind the reds and oranges of sunset. This is why sunsets are often so vibrant. You can see a similar effect at home with a simple experiment. Shine a flashlight through a glass of water with a little milk mixed in. You'll notice the light scattering and creating a bluish hue, just like our sky. Next, let's talk about soap. Ever wonder how it cleans your hands so effectively? It's all thanks to the chemistry of soap molecules. Soap molecules have two ends, one that loves water, hydrophilic, and one that loves grease and oil, hydrophobic. When you wash your hands, the hydrophobic ends cling to the oil and dirt, while the hydrophilic ends cling to the water. When you rinse, the water carries away the soap, taking the dirt and oil with it. This process is also why soap bubbles form. The hydrophobic tails try to avoid water, clustering together and trapping air inside, creating bubbles. Try this experiment at home. Mix oil and water in a clear container. Notice how they don't mix? Now add a few drops of soap and shake. Watch how the soap helps the oil disperse into the water. Microwave ovens are a kitchen marvel. They heat your food quickly and efficiently, but how do they do it? Microwaves produce electromagnetic waves that cause water molecules in your food to vibrate. These vibrations create heat, which cooks your food from the inside out. That's why foods with higher water content cook faster in a microwave. Inside the microwave, a device called a magnetron generates these waves. The waves bounce around the oven's interior, penetrating the food and causing those water molecules to jiggle. Here's an experiment. Place a marshmallow in the microwave and heat it for a few seconds. Watch how it expands. This happens because the microwaves cause the water molecules inside the marshmallow to heat up and create steam, which expands the air pockets in the marshmallow. Autumn brings a beautiful array of colors to the trees. But why do leaves change color? During the spring and summer, leaves are green because of chlorophyll, which helps plants make food from sunlight. As the days get shorter and cooler, chlorophyll breaks down, revealing other pigments like carotenoids, which produce yellow and orange colors, and anthocyanins, which produce reds and purples. Each tree species has a unique mix of these pigments, which is why we see such a variety of colors in autumn. Temperature, light, and water supply all influence the degree and duration of fall color. Try this fun experiment. Collect different colored leaves, crush them, and place them in rubbing alcohol in separate containers. Leave them overnight, and you'll see the pigments separate, revealing the hidden colors. Finally, let's explore the science of ice cream. Making this delicious treat involves both physics and chemistry. Ice cream is made by freezing a mixture of cream, sugar, and flavorings while stirring. The stirring prevents large ice crystals from forming, giving the ice cream its smooth texture. Air is also incorporated during this process, making the ice cream light and fluffy. The ideal temperature for serving ice cream is around -10 degrees Celsius, 14 degrees Fahrenheit. At this temperature, it's soft enough to scoop but firm enough to hold its shape. Want to make your own ice cream? Here's a quick method. Mix milk, sugar, and vanilla in a small Ziploc bag. Place it in a larger bag filled with ice and salt. Shake vigorously for about 10 minutes, and voila! Homemade ice cream. There you have it, the science behind some of our everyday phenomena. We hope you enjoyed this journey into the wonders of science. If you did, don't forget to like, subscribe, and hit the bell icon for more exciting content. See you next time.